This is Geometry Lesson 11.4. Geometry Lesson 11.4. What we're looking at today is geometric probability. We're going to do probability, but with geometric shapes. First of all, take a look at our little formula that we're going to be using for probability. Probability is the number of ways you can be successful divided by the total number of ways something can be done. So the number of ways you could be successful divided by the total number of ways. Okay, now what do you mean about that? Well, let's look at some problems here. First of all, this first slide, there's 5 slides today. This first slide is just an intro about probability. Let's look at this first one. What is the probability of getting a 6 when rolling one die? So think about it. Okay, here we go. The probability of rolling a 6. Now, well, hey, it's the number of ways I could be successful. The number of ways I could be successful over the total number of ways. Well, think about it. Here we go. Let's go look at this. Here we go. I'm rolling a die. I'm rolling one die. Here it is. I want to roll a 6. Roll a 6. There we go. Boom. I got a 6. Okay. Now, take a look back at our thing. What's on one die? What's the number of ways you could be successful to roll a 6? There's only one way because there's only one 6 on a die. How about the total number of ways? Yeah, there's 6 number of ways you could get a number. Now, I like to give our answer as a percentage. So here we go. Let's do it. 1 divided by 6. Clear it out. 1 divided by 6. There it is. Hey, let's put that down here. 0.16. Now, I want it as a percentage. What do you do to get it as a percentage? Yep, you move the decimal place 2 places to the right. Here it is, 16.6%. There we go. Okay, let's look at another problem here. Okay, now, what about this one? What's the probability of getting an even number when rolling one die? Well, here it is. Probability of rolling an even number. Well, on top, how many ways can you be successful getting an even number on one die? Now, there's 3 ways because you could roll a 2, a 4, or a 6. So there's 3 ways. How many total ways can you get a number on a die? Rolling one die, how many different ways? 6 different ways. Oh, there it is. That's 0.50. Okay, as a percentage, what do you got? Yeah, I got 50%. Let's keep on moving here. Okay, how about this one? The probability of rolling a 7 on one die. You got one die. First of all, on top, how many ways can you be successful? Yeah, 0. How many ways total can you get a number? Yeah, there you go. Hey, 0%. I just did that one just to show you. It's possible to have a probability of 0%. Okay, how about this one here? Okay, let's look at a baseball field here. Okay, so what's the probability of picking an outfielder from the 9 players out on the field? They're on the dugout, and you're just picking out three players, the outfielders from the 9 players. So here we go. The probability of picking an outfielder from the players out on the field. Okay, well, first of all, on top, the number of ways you could be successful. How many outfielders are there out there on the team? Again, they're on the field. They're on the field. How many players are the outfielders? Yeah, there's 3 players that are outfielders. Left field, right field, and center field. How many total players out there? 9. There it is, 0.333 as a decimal. Remember, I want it as a decimal. Move it over twice. Here's our answer, 33.3%. Okay, now let's do a little geometric probability. Let's go to this one. Okay, here it is. Point K is somewhere on that segment, AB, somewhere on that segment. What's the probability that point K is going to be on segment CD? Okay, so here we go. We want the probability that point K is on segment CD. First of all, number of ways I could be successful. Instead of thinking number of ways, think number of inches that I could be successful. To have point K on CD, yeah, 3 inches, because CD is 3 inches long, over the total. What's the total distance from A to B? That's going to be 13, 3/13. Let's get it first of all as a decimal. Here we go. 3 divided by 13. There it is. 0.2307. Okay. 0.2307. I want it as a percentage. Move it once, twice. There it is. 23.07%. There it is. Again, it was the distance that I would be successful divided by the total distance. Okay, now let's get to problems similar to homework. Let's do areas. That's what you're going to have in homework. It's going to be areas. So here it is. I've got a couple of circles here. A dart is thrown and hits the dartboard. Find the probability that the dart hits the red region. So I want the probability that I hit the red region. So think about it. Our formula is the number of ways you could be successful over the total number of ways. Well, in this one, we're not looking at number of ways, we're looking at area. The area of the red circle divided by the area of the total, or the big circle. So here it is. Hey, what's the area of the red circle? Well, it's going to be pi r squared, so it's going to be pi 3 squared. What's the area of the big circle? Well, it's going to be pi r squared, or pi 5 squared. We can do our work, or is there something that could cancel top and bottom? Yeah, on this one, those are gone. Here I have it. 9 over 25. Let's do it as a decimal first. Okay. 9 over 25. There it is. 0.36. 0.36 as a decimal. What do you think? Yep. 36%. So there's a 36% probability if your dart hits the board, and it is going to hit the board, that it will hit the red region. Really what we're looking at is we're looking at the red region divided by the total region. That's really what we're looking at. That's the end of part 1. Part 1. I've got 2 more slides to show you for lesson 11.4.